Water is such a common aspect of everyday lives that we tend to take it for granted, and we don't really appreciate that nearly all the water we come across is actually a solution, not pure water. Water has an amazing capacity for dissolving other substances. We call this property being a solvent. The sea contains many salts such as sodium chloride dissolved in the water. Fruit juice contains vitamin C, natural sugars, and fruit acids dissolved in the water. It is minerals dissolved in rainwater that causes stalagmites and stalactites to form in caves. Water running through industrial areas such as quarries or mines can easily dissolve pollutants, carrying them downstream dissolved in the river water. Soluble tablets are easy to swallow and work quickly because the active ingredient is already dissolved when it reaches the stomach. Cooks may dissolve a little salt in the water when boiling vegetables or making soups to enhance the flavour. Even what we think of traditionally as pure water really isn't. As rain passes through the air, it dissolves gases such as carbon dioxide, and when it flows in rivers and streams it can dissolve minerals out of the rocks. Fish and other living organisms add their share of organic matter to even the cleanest looking water, and we deliberately add substances such as chlorine and fluoride to water for health reasons. The ingredients label on bottled water shows that the bottle does not just contain water. Fish could not live in water if it wasn't capable of dissolving oxygen from the air. How much oxygen dissolves depends on the temperature of the water. The colder it is, the more oxygen will dissolve. It also depends on how much the water gets mixed with air. Fast-flowing rivers and waterfalls help to dissolve more oxygen. This, in turn, allows fish that use more energy and move more quickly to live there, which is why salmon live in very cold water. Hot water from industrial sites may be clean when it's released into rivers, but if it increases the temperature of the river, it will decrease the amount of dissolved oxygen, which in turn will affect aquatic life in the river. We call this thermal pollution. We need some specific vocabulary to discuss water's effect as a solvent. Firstly, we should recognise that once something is dissolved in the water, what we have is a liquid mixture that we call a solution. The substance that has dissolved in the water we call the solute. So in the example here, the solid blue copper sulfate is the solute, and it's being added to the water to form copper sulfate solution. We could keep on adding more and more copper sulfate, and eventually we'd get to the point where no more would dissolve, and the remaining copper sulfate would just lie on the bottom of the beaker. The solution is now said to be saturated. Just how much of the solute will dissolve depends on the temperature of the water. In general, if the water is hotter, then more will dissolve in it. To be precise about this, we define the solubility of a substance at a particular temperature as the number of grams that will dissolve in 100 grams of water at that temperature. Solubility graphs are used to show how the solubility of a substance varies with temperature. Shown here is the solubility graph for sugar in water. You can see that as the temperature increases, the mass of sugar that will dissolve increases too. For example, if we had 400 grams of sugar and we wanted to dissolve it in 100 grams of water, we can find 400 grams and read across to the curve on the graph and then down to find the temperature we'd need the water to be at. We can see that the water would have to be at least 88 degrees C for all the sugar to dissolve. In the same way, if our water is at 50 degrees C and we start adding sugar to it, we can see by reading from 50 degrees C up to the curve on the graph, then across to the y-axis, that we can add 260 grams of sugar and it will all dissolve, but after that any more sugar we add will not dissolve unless we add more water or raise the temperature of the water.